What scientists were initially ridiculed but later proved right. Story 1. Alfred Wegener. He developed the principle of plate tectonics largely built around some convincing but coincidental observations of the similar features in fossils found on East South America and West Africa. His theory wasn't accepted for nearly 50 years because no one at the time believed that there was any mechanism for massive land masses to move. To add to this, it wasn't accepted until 1968. He died in a blizzard trying to further prove his theory. We have known more about deep space, atoms, elements, computers, and nuclear bombs before we knew about some of the most basic inner workings of our planet. In a way, modern-day geological science is very young in comparison to the other sciences. It's groundbreaking, tee-hee. Story 2, ridiculed might be too strong of a term, but one figure in this milieu is Andrew Ellicott Douglas. Douglas was an astronomer during the early 20th century whose primary research interest was the sunspot cycle. From Wikipedia, the solar cycle, also known as the solar magnetic activity cycle, sunspot cycle, or Schwabe cycle, is a nearly periodic 11-year change in the sun's activity measured in terms of variations in the number of observed sunspots on the sun's surface. Over the period of a solar cycle, levels of solar radiation and ejection of solar material, the number and size of sunspots, solar flares, and coronal loops all exhibit a synchronized fluctuation from a period of minimum activity to a period of a maximum activity back to a period of minimum activity. Douglas's wild idea was the hypothesis that there would be a correlation between the sunspot cycle and patterns in tree rings. As you likely know, most trees grow in yearly cycles. When examining the core of the tree, you can observe how the tree has grown through its ring pattern, with each ring corresponding to a year. The outer ring corresponds to the most recent year, moving inward to its first year's growth. In order to examine this, Douglas developed a brand new scientific field, Dendrochronology, the study of tree growth through time. Trees growing in the same region tend to have quite similar ring patterns due to shared weather conditions. When there is significant rain, trees tend to grow more and vice versa. Because trees share these patterns, living trees can be compared to older trees and dead trees. If you have enough overlap and enough access to samples of dead trees, you can begin constructing a timeline which can potentially go back thousands of years. Story 3. Robert Hanbury Brown and Richard Twiss invented two-photon interference and pointed out it could be used to measure the size of stars. He faced widespread skepticism by physicists. Dirac himself declared that two photons could not interfere, and the idea was nonsense. He wrote 3 long papers explaining the idea, the subtleties, and how to measure it with the crude instrumentation of the 1950s. Then he built a radio telescope system and measured the diameter of every star, bright enough to be measured from Earth. People still didn't believe it and countered that it should be measurable using light sources in the lab. People tried to measure it and failed to see the predicted effect. Then he did the experiment correctly and proved it existed. Today, it is one of the most widely used techniques in optics, astronomy, and nuclear physics. Even though he lived another 45 years, he never got the Nobel Prize, one of their great omissions. Story 4. Sir James Young Simpson, 1811 to 1870. Sir James Young Simpson was a Scottish obstetrician and a pioneer in the field of anesthetics. After witnessing a surgery without the use of anesthetic, Simpson became an advocate for pain control. Simpson experimented with different anesthesia agents and became the first to use chloroform during deliveries. Chloroform was opposed by Christian fundamentalists and was viewed as unacceptable by the deeply religious society he lived in. Simpson used anesthesia despite being condemned by members of the church and the medical profession. He became the personal physician to Queen Victoria in 1847. In 1853, the Queen used chloroform during her delivery of Prince Leopold, making chloroform widely accepted in Britain. In 1866, Simpson was the first person to be knighted for advances in medicine. Story 5. The New York Times admitted rockets can work in space the day after Apollo 11 launched. A correction, on Jan 13, 1920, Topics of the Times, an editorial page feature of the New York Times, dismissed the notion that a rocket could function in a vacuum and commented on the ideas of Robert H. Goddard, the rocket pioneer, as follows. That Professor Goddard, with his chair in Clark College and the countenancing of the Smithsonian Institution, does not know the relation of action to reaction and of the need for something better than a vacuum against which to react. To say that would be absurd. Of course, he only seems to lack the knowledge ladled out daily in high schools. Further investigation and experimentation have confirmed the findings of Isaac Newton in the 17th century, and it is now definitely established that a rocket can function in a vacuum as well as in an atmosphere. The Times regrets the error. Story 6. Georges Lemaitre. He proposed what would eventually become known as the Big Bang Theory. He proposed that the universe was forever expanding, and even provided the math, based on general relativity, to back it up, and included the first estimate of the Hubble constant. This stood in direct conflict with the then popular steady-state model that dated from Aristotle. Lemaitre was particularly ridiculed because he was a Catholic priest. Of course, a priest would prefer a model of the universe that coincidentally allowed for a creation event. Story 7. It's not really a scientist, but back in the day, the idea of a platypus was originally ignored by many scientists who assumed it was a joke until one was sent into the Natural History Museum. There was a lot of discovery and exploration being done in the late 1700s, early 1800s, and fake animals had been presented as real before. I believe the guy who first examined and confirmed it was convinced it was going to be fake. Like a duck made love with a beaver, and the offspring also had venomous snake qualities, it doesn't sound real at all. That totally makes sense. If someone described a platypus to me without showing a picture, I'd probably think they were messing with me too. I mean, a mammal that lays eggs, has a duckbill, a beaver tail, webbed feet, and venom? It honestly sounds like something out of a fantasy novel or a drunken science experiment gone rogue. And considering the time period, late 1700s, early 1800s, when explorers were bringing back all sorts of weird stuff, some real, some totally fake, it's not surprising scientists were skeptical. I love the image of this serious museum scientist preparing to debunk it, only to be like, oh, wait, is this real? Must have been a wild day at the office. Story 8. Claire Patterson figured out the age of the Earth from lead-uranium ratios. That isn't why he was ridiculed, though. He kept finding his samples contaminated with extra lead everywhere in the world. He figured out that lead in burning gasoline and other industrial processes was everywhere. He grew concerned and started researching the health impacts. He started trying to bring public awareness to the problem. Other scientists in the Ethel Corporation, who supplied the lead in gasoline, reacted very poorly to this. He was ridiculed, refused research contracts, and generally treated like a crank. Slowly, his arguments gained ground. He countered their argument that some lead is natural by testing mummies and showing that they had much lower lead levels. The neurological toxicity of lead was better understood. Finally, lead in gasoline was banned, at least in most countries. Background lead levels have since been dropping. Patterson was vindicated. He did win some awards and had a minor planet named after him, 2511 Patterson. Story 9. The term imaginary numbers in mathematics was coined by Descartes to ridicule the entire concept. To him, it was something that just wasn't possible. No one person can really take credit for the whole idea of complex numbers, as we made slow progress towards them throughout the development of algebra. But Raphael Bombelli is the closest well-known contemporary to Descartes, who worked on the theory of I and first wrote down algebraic rules for complex arithmetic. The term imaginary, still used in canonical mathematical parlance today, would go on to ruin the understanding of billions of students throughout history and keep them embracing complex numbers because they aren't real. I is literally just the y-axis in the xy plane, so it's as real as the real number line. In this sense, Bombelli et al. Have yet to be truly vindicated. Many intelligent and well-informed people still think of complex numbers as a weird, abstract concept that doesn't actually exist because of how they learned about them in school. Story 10. I don't know about being ridiculed, but Bonnie Bassler, Princeton, had a lot of trouble finding a job partly because she couldn't find anyone who saw value in her work. Check out her talks on bioluminescence and quorum sensing. I got to have dinner with her when I was a postdoc. It was a lot of fun. I know there are other examples of profs telling their grad students that the research interests will get them nowhere when, in actuality, they broke big. If you hadn't asked this damn question, I'm sure I could remember. Now I'm gonna lie here in bed all night trying to remember. Story 11. Ridiculed by whom? Some have been ridiculed by great Yahoo swaths of the general public, but were recognized all along by by actual scientists, as being somewhere between very bright and absolute geniuses. There are a lot of people, I'm trying to phrase this without being unnecessarily cruel about it, a lot of people who are not scientists at all, and not mathematicians either, who think of themselves as unrecognized geniuses, who, when they are not welcomed with grand accolades by the scientific community, say things like, well, Einstein had the same sort of problems at first, but no, Einstein never had the same problems. Story 12, Nobel Prize winner Dan Shechtman, discoverer of quasicrystals. For a long time it was me against the world, he said. I was the subject of ridicule and lectures about the basics of crystallography. The leader of the opposition to my findings was the two-time Nobel laureate Linus Pauling, the idol of the American Chemical Society, and one of the most famous scientists in the world. For years, till his last day, he fought against quasi-periodicity in crystals. He was wrong, and after a while I enjoyed every moment of the scientific battle, knowing that he was wrong. Wow, that quote is so raw and real. You can feel the weight of what Shechtman went through, going up against the entire scientific establishment, including someone as legendary as Linus Pauling. That takes serious guts. The fact that Shechtman stuck to his findings even while being ridiculed, not just disagreed with but mocked, shows a level of conviction and integrity that's honestly rare. And then to be right, after all that must have been equal parts vindicating and surreal. Story 13, all of them. We live in a society based on reductive compliance to strict norms, and one that punishes deviance. Nearly the entirety of archaeologists adhere to a surprisingly Christian 6,000-year-old worldview, because actual evidence to the contrary has been historically punished despite the original notes and evidence of those theories being very divergent from the norm. Those theories never survive contact with their peers, even when, for example, you get a carbon-dated, anatomically modern human femur that is 1.2 million years old. I could go on and on about this, and despite several books about this that have been written, academia is quite insular and not remotely the kind of free exchange of information we are told exists. And this isn't even dealing with the funding problem. Story 14, Mary Anning was simply an incredible person. She grew up seeking dinosaur fossils with her dad and brother, but after her dad died and her brother took over the family's finances, she had to find the fossils she had previously found as a group. The Natural History Museum says that when she was just 12 years old, she and her brother found an ichthyosaur head on the beach in England. Anning then dug out the remainder of it. Scientists at the time dubbed it a crocodile, and a lot of other things that weren't what it was. It was only when the heads of the scientific community, all men mind you, agreed it was a prehistoric monster that it got that name. A lot of the time, the same men would buy Anning's skeletons, figure out what they were, tell the world, and never give her credit. That wasn't even the worst part. Anning would later find the first complete plesiosaurus skeleton. It was an astonishing discovery for a scientific community that didn't care about her. Of course, they said the fossil was fake and didn't give Anning any credit. George Cuvier, who is known as the father of fossil finding, even disagreed with it. The Geological Society of London conducted a special conference when Cuvier had to concede he was wrong. Story 15, the body is indeed an amazing thing. The Cleveland Clinic says that if you stretched out all of its arteries and veins, they would be 60,000 miles long, which is enough to encircle around the world twice. There are 79 organs, 206 bones, and a brain that is still a mystery. A few hundred years ago, we didn't know much more about the body than we do now. According to Medical Daily, William Harvey was a man who had figured out how blood moves through the body. In 1628, he published his findings, but the scientific community was still stuck in their old ideas, which went back to the 2nd century when a doctor named Galen said that the liver made blood from food and sent it to the heart and lungs. That sounds crazy today. Even though Harvey knew the real facts about the heart and circulation, his peers still held on to ideas that were 1,500 years old. They didn't just hold on to those ideas. They also rubbed Harvey's nose in his own views. Rob Dunn's book, The Man Who Touched His Own Heart, True Tales of Science, Surgery, and Mystery, says that Harvey became a recluse because things got so awful. He completely cut himself off from the outside world to avoid being made fun of. He was even cited as stating, "It is often better to grow wise at home and in private than to publish what you have worked so hard to get, which will cause storms that will keep you from peace and quiet for the rest of your life." Story 16. In the modern world, coming up with new and exciting ideas has always been a risky business. At best, you risk being laughed at and mocked, and at worst, you risk going crazy from not getting any approval, though that doesn't happen very often. In the Middle Ages, however, it was a whole different story. For instance, Michael Servetus. Servetus was a doctor and a theologian, yet some of his ideas didn't fit with what the church taught, specifically his ideas about how blood flows via the lungs. Servetus wrote a book about his ideas, but it also had a lot of negative things to say about the church and Christianity. This probably wasn't the best place to store important information regarding pulmonary circulation, but it was a different time. The whole text was still considered heretical nonetheless. What part? That's a good question. The Catholic Church thought that all of it was erroneous. Thus, Servetus's ideas concerning the pulmonary system were likewise heretical. This could have been by chance, or because the Catholic Church didn't like what he said about human lungs. No matter what, he made the church so mad that both Catholics and Protestants believed he was a heretic. Sadly for Servetus, this got him put on a burning stake with a bunch of his books. Story 17. These days, almost everyone knows who Galileo is, but back then, he could have been burned at the stake for saying what is now such an obvious fact, that the Earth circles around the sun. He authored a book called Dialogue concerning the two chief world systems, in which he explained why he thought it was wrong to say that the Earth is not the center of the universe. This did not sit well with the Pope, who was never a fan of having his opinions questioned, like most things that go against traditional Catholic principles. The Inquisition was going on, and that meant that anyone who dared to disagree was put to death. Why have a rational conversation when you can just burn the other side? In a strange twist, the Pope liked Galileo a lot and gave him some money to keep working on his projects. The Pope had no idea what he would find. The Earth was moving. The center of the universe shouldn't be moving, that's for sure. Galileo was arrested for heresy and had to take back what he had said, which he did, but it didn't affect what he really believed. Story 18. You undoubtedly learned about Gregor Mendel in science class in elementary school. Mendel, a Moravian Augustinian friar, is known as the father of modern genetics. In his free time, he crossed pea plants to see what would happen. He might not have been thought of as a crazy person at the time, but his experiments weren't very well known or appreciated either. Mendel's garden pea plants helped him come up with the terms recessive and dominant to talk about genes. He mostly kept them to himself, and they weren't fully acknowledged until after he died. Scientists used to think that features were passed down to the next generation by blending inheritance, which means that they were averaged and mixed together. Mendel passed away in 1884, but it wasn't until the early 1900s that people started to call his concepts modern genetics. Story 19. Before Jon Snow became a fan-favorite actor on Game of Thrones, the name was renowned for the man who found out how cholera was spreading in England in the 1800s. Snow had long thought that the sickness was spread through dirty water, but at the time, the most common theory was that breathing in filthy vapors was to blame. At this time, people thought bad air was to blame for a lot of things. People didn't like his notion, but Snow persisted hunting for proof. He started keeping track of the contamination radius after a cholera outbreak ended 500 people in his neighborhood. He uncovered clear proof that every case came from drinking water from a certain town pump. It was even more telling that the prison in the area, which housed hundreds of inmates, didn't get a single case of cholera. They were basically breathing the same air as the sick folks, but the prison had its own well. Officials still wouldn't accept Snow's claim, even though there was so much proof against it. That is, until an article came out that proved a leaky cesspool just a few feet from the pump was probably to blame for the deadly outbreak. Story 20. The Wright brothers first offered the US government the airplane, but they kept saying no. Different people react differently when they hear no over and over. For some, it makes them so unhappy that they give up. It pushes some people forward. The Wright brothers were in the second group. You might be shocked to find out that not everyone was excited about Orville and Wilbur's flying contraption. Even though they had pictures of their successful flights, a lot of people in the early 1900s just couldn't imagine people flying. The US government turned down the brothers' innovation many times when they tried to sell it to them. They wanted to keep their invention a secret in their own country, but their government wouldn't let them. It wasn't until France became interested in the technology that American officials finally took notice in 1908. more than 5 years after the Wright's first successful flight. Story 21. Billy Mitchell was yelling from the rooftops about how important jets were long before Tom Cruise made them cool. He thought that air power was the future of war. Mitchell, a U.S. Army general who was as subtle as a cannon, spent the 1920s warning that planes would change the way wars were fought. He also warned anyone who would listen that the Navy of the United States was quite weak. The military court-martialed him for disobeying orders after he physically bombed a captured warship from the air to make his point. He quit as a colonel because he was tired of the army not listening to him. Just like Mitchell said, Japanese planes sank battleships at Pearl Harbor 15 years later. Story 22. People today know that elite athletes' brains can occasionally be ticking time bombs. Chronic traumatic encephalopathy, or CTE, can happen if you hit your head over and over again. So you might be surprised to learn that the man who found CTE in NFL players got a lot of opposition. Bennett Omalu's research on former NFL players should have been a big deal. The NFL, on the other hand, tried to hide it. In 2005, Omalu's research that linked frequent head trauma to long-term brain damage was first sought to be taken back, but people laughed at it. Other discoveries were ignored or flat out denied. But as more former gamers lost their memories, grew violent, and hurt themselves in horrible ways, the reality became clear. The league had to admit that concussions were dangerous, which led to huge lawsuits and changes to the rules of the game. Story 23. Fudai, Japan, chose Kotoku Wamura as mayor after World War II, expecting he would rebuild the town. They clearly liked what they saw, since they kept voting for him until 1987. Wamura remembered that a tsunami hit Fudai hard in 1933. They had been hit by another one decades before that. The mayor promised that it would never happen again. In the 1970s, he got a huge 51-foot floodgate built. People made fun of it as being too much work for a public initiative. People who didn't like it complained it marred the view. Wamura was adamant. He died in 1997, but he was right in the end when the tsunami hit Japan's shore in 2011. Fudai, on the other hand, was safe. The wall he built that everyone made fun of protected the whole town.